Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good morning, parents, teachers, and learners. Welcome back to our Mathematics 9 Valenzuela Live. We are now on the second quarter, week number 3. Please be ready with your ADM or modules and open it to zero and negative exponents section. Make sure that your pen and paper are with you for solving and note-taking purposes. Today, we will deal on the zero and negative integral exponents. The topic is the continuation of your previous lesson in your previous grade levels about the rules or laws of exponents. Let me present to you our objectives for today. At the end of the discussion, you should be able to identify the laws involving zero and negative integral exponents and simplify mathematical expressions using the laws of exponents. If you can recall, we have the first three rules or laws of exponents, namely the product rule, the quotient rule, and the power rule. The principle of the power rule can be applied in multiplication, as stated in the power of a product rule, and also in division, as stated in the power of a quotient rule. Before we dig in our topic for today, let us have an activity called What's in the Magic Hat? In this activity, we need to unlock and discover a 6-letter word, and we can only do that by answering the questions that will be provided. We need to choose one of the magic hats that best describe our answer. The correct hat has a letter clue to our mystery word. So again, the letter clue will be used to unveil our mystery word. We are only given 10 seconds to answer each question. So are you ready? Let's start. Item number 1. Evaluate 4 squared. Is it the red hat that corresponds to 8 or the orange hat that corresponds to 16? Type the color of the hat. Your 10 seconds starts now. If you dropped the orange hat, you are correct. Common mistake in evaluating this kind of expression is by multiplying the base 4 and the exponent 2. That is why some commit error of having an answer that is 8. This is incorrect. Remember that the exponent tells us how many times the base will be used as a factor. Since we are given with 4 squared, whose base is 4 and exponent of 2, it means that the base 4 will be used as a factor twice. Thus, we have 4 times 4, that is equal to 16. Let us find out what is the first letter clue that we have. The first hat has the letter N. Let us answer some more questions to reveal the hidden word. Item number 2. Simplify the expression quantity 2ab squared. What is its correct simplest form? Is it the red hat, 2a squared b squared? The orange hat with 4a squared b squared? Which one? 10 seconds starts now. Is your answer 4a squared b squared? That is perfect. The expression can be simplified using the concept of the power rule. To be specific, the power of a product rule. If a power is raised to another power, copy the base, then multiply the exponents. So, the exponent outside the parentheses will be multiplied to each exponent in every factor. The expression can be written as 2 raised to 1, a raised to 1, b raised to 1, all of them raised to 2. Note that 2, a, and b each has an exponent of 1. Multiplying the exponent 2 outside the parentheses to each of the exponents, we will obtain, correct, 2 squared, a squared, b squared. Simplifying this further, it will result to 4a squared, b squared. Since we answered the question right, another letter clue will be given, and that is a letter A, which is the second letter of our hidden word. Let us proceed to the next item. Number 3 is given by multiply 3y raised to 4 and 2y cubed. Is it 6y raised to 12 for the orange hat? Or 6y raised to 7 for the green? What will you choose? Orange or green? Timer starts now. If you answered 6y raised to 7 and you drop the color green, that is excellent. 3y raised to 4 and 2y cubed can be multiplied using the product rule. When multiplying exponential expressions with the same base, we copy the common base, then add the exponents. So first, we multiply the numerical coefficients or the numerical factors 3 and 2. To multiply y raised to 4 and y cubed, we copy the common base y, then add the exponents. Thus, if we are going to simplify this, 3 times 2 is 6. 4 plus 3 for the exponents, we have 7. Thus, we have 6y raised to 7. You are doing a great job. Let us find out what the next letter will be. The next letter clue is letter T. And it is the last letter of our mystery word. 3 more left and our task is solved. The next one, divide a cubed, b squared, and ab. Is it a squared b given in the orange hat? Or a to the 4th b cubed given in the green hat? 10 seconds, go. If you answered orange, you are great. We can use the expanded form or the rules or laws of exponents in answering this question. But in our case, let us apply the quotient rule. So in dividing exponential expressions with the same base, we copy the common base, then subtract the exponent of the numerator by the exponent of the denominator. In our case, we rewrite the expression by putting exponent 1 to both a and b in the denominator to avoid confusion. Then, we copy the first common base a, then subtract the exponents. We have 3 minus 1. Same process will be applied for the second base b. Subtract the exponents. We have 2 minus 1. If we are going to perform the indicated operations in the exponent, the result will now be a squared b. Are you ready for the 4th letter? What letter will it be? It is the letter G. It is the fourth letter of the word. Do you have an idea of what the mystery word is? Or maybe some of you already know it, but let us continue solving. Let us go to item number 5. Simplify the square of 2a cubed over 3b raised to 4. For the orange hat, 2a raised to 5 over 3b raised to 6. For the green hat, 4a raised to 5 over 9b raised to 6. And for the red hat, 4a raised to 6 over 9b raised to 8. What is your answer? Timer starts now. If you chose the red hat with 4a raised to 6 over 9b raised to 8, you are correct. To simplify the expression, we will use the power of a quotient rule, still under the power rule. We rewrite the expression by putting exponent 1 to the bases 2 and 3. Multiply the exponent 2 outside the parentheses to each of the exponents in the numerator. Thus, we have 2 squared a raised to 6. Same process will be applied for 2, the exponent outside the parentheses, and the exponents in the denominator. By multiplying, we will obtain, correct, 3 squared b raised to 8. Squaring 2 and 3, the resulting expression is 4a raised to 6 over 9b raised to 8. The second to the last letter is H. What is the mystery word? Type in your answer and let us verify after answering this last question. The last question is, simplify the cube of 3a squared b cubed. Is it 3a raised to 5 b raised to 6? Or 27a raised to 6 b raised to 9? Or 27a raised to 5 b raised to 6? 3 hats, 1 is correct. What will it be? What is your answer? 10 seconds to simplify. Go. The correct answer is in the green hat, 27a raised to 6, b raised to 9. It seems that you are remembering the topic well. We can simplify this by applying the power of a product rule. We can rewrite the expression as the cube of 3 raised to 1, a squared, b cubed. Multiplying the exponent outside the parentheses, that is 3, to each of the exponents, we have 3 cubed, a raised to 6, b raised to 9. Simplify by cubing 3. The result is now 27a raised to 6, b raised to 9. That's exceptional. I know that your teachers are also happy knowing that you still remember the lesson about exponents. To finally reveal the word, let us unveil the last letter. It is U. Did you guess it right? The word is north. Since one of the topics that will be discussed for today is zero exponent, let us have some trivia about it. Zero is called north in other places and said to be the old-fashioned way of calling it. Other terms that means zero are nil, null, O. Example for this is saying the number of the room 304, and changing A to O in our mystery word. You did great. the concepts that we had in the activity about the rules or laws of exponent will be applied to our topic for today. How about if we are given with b cubed over b cubed? How are we going to simplify this expression? To simplify b cubed over b cubed, we can use the quotient rule. We copy the common base b, then subtract the exponents. Simplifying this by subtracting the exponents, the result will now be b raised to 0. On the other hand, we can use the expanded form. We have b cubed over b cubed can be expanded as b times b times b all over b times b times b. Canceling common factors will result to 1. 1 divided by 1 equals 1. From the statements, we can say that b cubed over b cubed is equal to b raised to 0 using the quotient rule. Simplifying this further will give us the answer of 1 using the expanded form. Why is this so? The zero exponent rule states that any number x except 0 raised to the power of 0 is equal to 1. This is the reason why the expression b cubed over b cubed and b raised to 0 is equal to 1. Let us have some examples of simplifying exponential expressions using the zero exponent rule. Example number 1. The zeroth power of 2xy squared, or quantity 2xy squared raised to 0. We can apply the power of a product rule. We can rewrite the expression as quantity 2 raised to 1, x raised to 1, y squared raised to 0. Then, we multiply 0 to each of the exponents inside the parentheses. The result is now 2 raised to 0, x raised to 0, y raised to 0. Applying the zero exponent rule, 2 raised to 0 is 1, x raised to 0 is also 1, y raised to 0 is 1. 1 times 1 times 1 is equal to 1. Next example, example number 2. Simplify 3x raised to 0. In 3x raised to 0, we should take note that the only expression or factor raised to 0 is x. The exponent of 3 is 1. Using the zero exponent rule, x raised to 0 is equal to 1. Thus, we have 3 times 1. So therefore, we can say that 3x raised to 0 is just equal to 3. Let us now proceed to example number 3. Simplify negative 4x squared y raised to 0 z cubed. First, it is important to note the variable or the factor that is raised to 0 exponent. In this example, y is the only factor or expression raised to 0. So applying the zero exponent rule, we all know that y raised to 0 is equal to 1. Now we have negative 4x squared times 1 z cubed. So by multiplying the result, we will now obtain the final answer. And that is negative 4x squared z cubed. Example number 4. Simplify 12ab cubed c raised to 4 all over 4abc raised to 4. If you can see, we can divide the numerical factors 12 and 4. 12 divided by 4 is equal to 3. Then let us apply the quotient rule. The first common base is a. Subtracting the exponents, that will be 1 minus 1. The second common base is b. Subtracting the exponents, we have b raised to 3 minus 1. Then the third common base is c. Subtracting the exponents, we have c raised to 4 minus 4. Now, if we are going to subtract the exponents, we have 3a raised to 0, b squared, c raised to 0. We use the zero exponent rule since a and c are raised to 0. Then, it will be 3 times 1, b squared times 1. By multiplication, the answer is 3b squared. I hope that you can still follow our lesson for today. The last item is simplify 8a raised to 0 plus b raised to 0 plus 2c raised to 0. As we can see, the variables a, b, and c are raised to 0. Using the zero exponent rule, we have 8 times 1 plus 1 plus 2 times 1. By multiplication, it will be 8 plus 1 plus 2, which is equal to 11. So therefore, this expression is equal to 11. So after dealing with zero exponent rule, let us have the next topic. Let us consider this. How are we going to simplify the expression given by b squared over b raised to 5? Just like what we did in the case of the zero exponent rule, we can simplify b squared over b raised to 5 using the quotient rule. B squared over b raised to 5 is just equal to b raised to 2 minus 5. Subtracting the exponents, 2 minus 5 will result to negative 3. Hence, we have b raised to negative 3. Likewise, if we will apply the expanded form in simplifying, we will obtain b times b for b squared over b times b times b times b times b for b raised to 5. We can cancel out common factors, b times b, since it is equal to 1. Thus, if we are going to multiply, that will be 1 over b cubed. What we have in the quotient rule, b raised to negative 3 is not yet the simplest form. Its simplest form is given in the result of the expanded form, that is 1 over b cubed. Thus, we can say that b squared over b raised to 5, which is equal to b raised to negative 3 using the quotient rule, b raised to negative 3 is also equal to 1 over b cubed. That is considered as the simplest form of the given expression. As stated in the negative exponent rule, x raised to negative n is just equal to 1 over x raised to n. And 1 over x raised to negative n is just equal to x raised to n. We should take note that x should not be equal to 0, and n is a natural number. If you can see, if the exponent of a certain variable or factor is negative, we just need to take its reciprocal, then change the exponent to positive. Let us have some examples in simplifying exponential expressions using the concept of the negative exponent rule. Example number 1. Simplify x raised to negative 6. According to the negative exponent rule, if x raised to negative n, then it will just be 1 over x raised to n. X raised to negative 6 is in the form of x raised to negative n. So therefore, we can apply this rule. We just get the reciprocal of x raised to negative 6, then change the sign of the exponent to positive. Remember that x raised to negative 6 has a denominator of 1. Getting its reciprocal and changing the sign of the exponent to positive, the final answer will now be, that's great, 1 over x raised to 6. Let us have the other example. Example number 2. Simplify 1 over b raised to negative 3. According to the negative exponent rule, if the given is 1 over x raised to negative n, so in this form, it will just be x raised to n. In other words, we get the reciprocal of 1 over b raised to negative 3. Then we change the sign of the exponent to positive. So it will be b cubed over 1, which is equal to b cubed. So therefore, we can say that 1 over b raised to negative 3 is just equal to b cubed. Let us proceed to example number 3. Simplify 6a raised to 4, b raised to negative 2, all over c raised to 4. It is important to observe and identify the factor that has the negative exponent. In this case, it is b raised to negative 2. Very good. It means that b raised to negative 2 is the only factor where we can apply the negative exponent rule. Rewrite or copy 6a raised to 4 over c raised to 4 as is, since their exponents are already positive. B raised to negative 2 will now be 1 over b squared, using again the negative exponent rule. Simplifying, 6a raised to 4 times 1 is just 6a raised to 4. And then, c raised to 4 b squared, if we are going to multiply the denominators, it will result to b squared c raised to 4. Thus, the final answer to our given expression is 6a raised to 4 over b squared c raised to 4. Let us now go to example number 4. Simplify quantity 2a squared over b cubed raised to negative 2. In simplifying this expression, we first apply the power of a quotient rule. We multiply the exponent outside the parentheses, which is negative 2, to the exponents inside. Remember that 2 has the exponent 1. Then, we multiply negative 2, the exponent outside the parentheses, to each of the exponents inside the parentheses. So it will be 2 raised to negative 2, a raised to negative 4, all over b raised to negative 6. From this expression, we apply the negative exponent rule. Take note that 2, a, and b are all raised to negative exponents. 2 raised to negative 2 will be 1 over 2 squared. A raised to negative 4 will now become 1 over a raised to 4. And finally, the denominator b raised to negative 6 will be in its form b raised to 6 over 1. Simplifying the expression further, by multiplying all the numerators and the denominators, it will become b raised to 6 over 4a raised to 4. Can you still follow? Are you still doing good? That's great. The last example is to simplify 5 raised to negative 2, a raised to negative 4, b raised to 0, all over quantity 3a raised to negative 2. To simplify this, we need the power rule to simplify quantity 3a raised to negative 2. On the other hand, we will apply the zero exponent rule to b raised to 0, since b raised to 0 is just equal to 1. So it will become 5 raised to negative 2, a raised to negative 4 times 1, all over 3 raised to negative 2, a raised to negative 2. Simplifying this expression, we now have 5 raised to negative 2, a raised to negative 4, all over 3 raised to negative 2, a raised to negative 2. From this, let us apply the quotient rule. The common base is a. So we copy first 5 raised to negative 2 over 3 raised to negative 2. And we now have the common base a, wherein the exponents will be subtracted. So we have negative 4 minus negative 2. So we all know that negative of negative 2 will become positive 2. So hence we have negative 4 plus 2. Therefore, it will be 5 raised to negative 2, a raised to negative 2, all over 3 raised to negative 2. From this expression, we apply the negative exponent rule. We all know that 5, a, and 3 are all raised to negative exponents. So, 5 raised to negative 2 will become 1 over 5 squared. On the other hand, a raised to negative 2 will become 1 over a squared. And finally, the denominator 3 raised to negative 2 will be in its form 3 squared over 1. Multiplying the fractions, we will obtain, multiply first the numerators. We have 1 times 1 times 3 squared, it will become 9. Multiply the denominators, 5 squared times a squared times 1 will be 25a squared. Thus, the simplest form of this given expression is 9 over 25a squared. We are now through with our topics for today about the rules or laws of exponents, which focused on the zero and negative integral exponent rules. Let us now sum it up. There are 3 different rules or laws of exponents discussed during the previous grade levels, such as the product rule, quotient rule, and the power rule. In the power rule, it includes the power of a product and power of a quotient rules. The next one is the zero exponent rule. It states that any non-zero number raised to 0 is equal to 1. Lastly, the negative exponent rule. And it states that if an expression has a negative exponent, we just need to get its reciprocal, then change the exponent to positive. I hope that you've learned something for today about the zero and negative integral exponents. We will now proceed with the question and answer. A question coming from a random student viewer: how do you call 0 raised to the power of 0? 0 raised to the power of 0 is either undefined or indeterminate in form. There is an argument that's still not yet resolved about the value of 0 raised to 0. Some claim that it is equivalent to 0. Some claimed that it is 1, and others claimed undefined. That is why it might be called as undefined or indeterminate in form. This question will be answered as you go on your higher mathematics, such as the calculus. If you have some more questions and verifications, you may ask your respective math teachers during your follow-up discussion. And for your home learning task, on your ADMs or modules, answer what's more. Keep trying numbers 1 to 10 on page 14 that deals on simplifying exponential expressions using the rules or laws of exponents. Once again, this is Sir Jude saying, solving math problems might be challenging. I know that. We know that. But use this as an argument or instrument rather to make you develop your critical, logical, and creative thinking. Good day, God bless, and stay safe.